In this video, we'll learn what variables are from a conceptual perspective. This will allow you to better understand how to use variables in your programs. I'm assuming in this course that everyone is familiar with the basic architecture of a typical computer system. That is, memory, a CPU, and a bus that allows the movement of data between the CPU and memory. Random access memory, or RAM, is a contiguous block of storage used by the computer to store information. This information can include computer instructions as well as data. RAM can be thought of as having memory cells, where each cell has an associated location. If we had to program using the specific memory locations, it wouldn't be a lot of fun, and we'd likely have a lot of programmer errors. Imagine saying something like, move 21 to memory location 1002. In many very low-level languages, this is sometimes what we do. However, most programming languages allow you to associate a name with a memory location. Let's see the same example using a variable. In this example, you can see that the memory location 1002 has been associated with the name age. In computing, this is called a binding, and we can move 21 to age. This allows us not to have to worry about what exact memory location age is associated with. If we run the program again, age will likely be associated with a different memory address, and that's okay, since we never knew about it in the first place. Our code will still work. Also, thinking of names that make sense to us makes writing and reading programs much easier. That's the basic idea behind names and variables. Of course, since age is a variable, that means that its contents can vary. So if we turn 22 years old, we can change the value of age from 21 to 22. So to recap, a variable is an abstraction for a memory location. We use abstractions all the time in programming to make it easier for us to deal with complexity. Variables allow us to use a meaningful name to represent a value. It's important to understand that variables have two main properties. First is their type. The compiler needs to know what types of values are legal to store in age. In the first code snippet on the left, we tell the compiler to store 21 in age, but we never told the compiler what is valid to store in age. This will produce a compiler error telling us that age hasn't been declared. In the code snippet on the right, we first declare age to be an integer. Now the compiler knows that only integers are allowed to be stored in age. This is called static typing because the compiler is enforcing these rules when the program is compiled rather than when the program is executing. So remember, variables must be declared before you use them in C++. Their value or contents may change as the program executes. In the next video, we'll learn how to declare and initialize variables so they're ready to use in our programs. Let's go there next.